Okay, we are given that if PQRS is a parallelogram, then the sum of unshaded region is that. So this is the unshaded region, the sum. Okay, before I will solve this, let me add an auxiliary line. That's my auxiliary line. So I will use a combined property of a parallelogram and a trapezium. So we have a trapezium in a parallelogram because this is parallel side. And in a trapezium, the area here and here are the same. Yes. So if here is A, here is also A. And the product of this, the product A times A, will be equal to the product of that 4 times 25. So making A, this A square root of 4 times 25 is 10. That's 100. Square root of 100 is 10. So I'm saying that this is 10 and this is 10. They are equal. As far as this is the area formed by the non-parallel side, they are equal. I will show you later. The area, this area, if you add it with this, it will give us this. Yes, if you add this and this, it will give us that. So what am I saying? That Pu of x is now 25 minus 4, which is 21. I will still explain later. If you add this, and this, it will give us this. I will explain, I will prove it later. So what was our answer? Our answer is 21. So the area we are looking for, the area of unshaded, the sum unshaded is just 21 plus 10 plus 10. So our answer is 41 cm squared. So it's very fast, option A. So let me now prove this, the concept that I used here. So I'm going to use 3 different diagrams. That ABCD is a trapezium. So this is a trapezium. So we have to find that, to show that this equals that. Okay, we start by drawing an auxiliary line. So assuming, okay, let's label here. Let's label DC as A. Y this H. This is also H from the same point. So we now see that area of triangle ADC, triangle ADC. Remember, area of a triangle is half base times height. So half the base is A times height, which is H. That's the first thing you have to know. Again, if you notice, area of triangle BCD is also have A times height. See, BCD. So again, the same base is half A times H. So what do you notice? We now see that triangle, that area of triangle ADC is the same thing as area of triangle BCD. And if you look at it, you notice that the two triangles have common area. They have DEC. So assuming if I label triangle AED, the area is A1. So let area of triangle AEB be A1, while area of DEC be A2. Finally, area of this be A3, BEC. You now see that ADC is the same thing as A1 plus A2. While area of BCD is the same thing as A3 plus A2. Therefore, ADC is A1 plus A2 and BCD is A3 plus A2. So what do you notice? They have common term, which is A2. Therefore, A1 must be equal to A3, which is what we are asked to prove. A1 is area of triangle AED, while A3 is area of triangle BEC. We are asked to show that area of triangle AED times area of triangle BEC equals area of triangle AEB times area of triangle DEC. So let's call this, if we call this A1, call this A2, we'll call this A3, and finally we'll call this A4. So we're asked to find that the products, that's the opposite areas that are equal. If you multiply this, that is equal to this, the product of this. Okay, let's call the angle here theta. We know by vertical angle theorem this is also theta. Again, this is a straight line, so this should be 180 minus theta. Again, by vertical angle theorem, this is also 180 minus theta. So again, let's denote AE. You know this E. Let's call AE A. Why this is B. EC B. Again, DE, let's call it C. Finally, EB, let's call it D. So as you can see, we have SAS triangles here. So we find the area. So we now see that A1 is half the area, half AC sine theta. Do you remember? Area of a triangle given two sides and an included angle. That's it. Again, A2 is half BD sine theta. A3 equals half A3 half BC sine 180 minus theta. And we know in trigonometry sine 180 minus theta is sine theta, second quadrant. So we have half BC sine theta. And finally, A4 is half AD sine 180 minus theta, which is half AD sine theta. So let's now multiply A1 times A2. A1 A2 is now half AC sine theta times half BD sine theta. Half times half is 1 over 4. We have 1 over 4 A, B, C, D sine square theta. So again, let's do A3 times A4. We have half BC sine theta times half AD sine theta. Again, we have 1 over 4 ABCD sine square theta. So as you can see, the two have the same results. So from here you can see that A1 times A2 is equal to A3 times A4. As far as this, this is a trapezium. Multiply the two opposite areas. They are always equal to the product of the other two areas. We are giving this a parallelogram, meaning all the sides are equal or congruent. This and this are the same because the area, if you remember, area of a parallelogram is base times height. And looking at this, assuming we have our height to be h, why this is our base. So we know that area is height. Let me write height. So we know that area is area of a parallelogram is base times height. Again, we know that area of a triangle is half base times height. So yes, so we are now saying that if we call area of triangle EDC A1, the remaining area to be A2 and A3, you can see that A1 is half of the area of the parallelogram. That's ABCD. Yes, because as you can see, they have the same base and the same height, so it's half of that. Base times, they have the same base and height. For area of A1 to be half of that implies that the remaining area, which is A2 and A3, the sum will also be half the area of the parallelogram. That is half of area ABCD. So because this is half, the remaining will be the remaining half. So I'm saying that A1 is the same thing as A2 plus A3. So we need to know this. That likewise this, that the same A1, A2, A3. So that A1 is A2 plus A3. Okay, I want to get the relationship connecting this. Okay, if we call here A1, we call here A2, we know that here is AA. From what I, because they say it's a parallelogram, so this is a trapezium because the sides are parallel. So this is AA, A1, A2. So if you call here maybe A3, so we will notice that, remember this is a parallelogram, the area here and here are the same because they have the same base, as you can see. So and the same height. And area of a triangle is half base times height. So for this triangle VSU, the area is half base times height. Okay, from the diagram we can see that area of this parallelogram STUV is base times height. So that's the formula. And area of triangle is always half base times height. So for this triangle FVU is now half base times what? Height. And this happens to be half the area of the parallelogram STUV. So this implies that the ones that are remaining, that's this triangle and this, if you sum the area, it will be equal to half of the area of the parallelogram, making the area of these two to be the same. So which implies that area of triangle FVO to be the same as area of the sum of the area, this and this, that's triangle SFV, and area of triangle FTO. Since both this is half, the sum of these two will be half, again half of the, making the two to be equal. So what am I saying? I'm saying that this area, this is A plus A1, must be equal to, that's A plus A2. A plus A2 is that must be equal to A plus A1 for this plus A3. So do you see the logic? This, the sum of this and this will be equal to this. So looking at this, there are common terms. A is common. So this is just a combination of trapezium property and parallelogram. So this is off. A is off. So we have that A2 will be equal to A1 plus A3. So have you seen it? That if you add this area, this, it will give you this.